In this video, we're going to look at how to convert any base 10 number into base n form. So there is a definite algorithm to this, and if you would like, you can write a method to do this in Java to see if you really understand it. In fact, you could write it in any language to see if you really understand this. So let's go through this. What we're going to do is we're going to convert 78 into base 2, then into base 5, and then into base 16. So to do this, what you do is you start by taking your number, which in our case is 78, and you divide it by the base. So if I want base 2, I'm going to divide it by 2. And there's two things that I really want to pull out of this. One is that I want to pull out is I want to pull out when I divide it what I actually get. So I get 39, and then I also want the remainder. This is going to give me a remainder of 0. So then what I do is I take the 39 here, we're going to ignore the remainder for a second, and I perform the same process again. So I'm going to take now 39 and I'm going to divide it by 2. So 39 divided by 2, it's going to give me 19, remainder 1. Now again, you could do this using long division form. I'm simply pulling out my calculator and writing the dividend and the remainder. So now I'm going to take 19, I'm going to divide that by 2. And this is going to give me 9, remainder 1. Now I'm going to take 9, I'm going to divide that by 2. And this is going to give me 4, remainder 1. And now I'm going to take 4 and divide that by 2. And that's going to give me 2, remainder 0. Then I'm going to take 2, and I'll divide that by 2. And that's going to give me 1, remainder 0. And finally, I'll take the 1, I'm going to divide 1 by 2. It's going to go into its 0, remainder 1. And that's the indication that I can stop now. I know I can stop when I end up with the 1 there. So now what happens is I can actually string these remainders together to get the base 2 representation of 78. So what I do is I start, however you want to do it, you can start writing from the left to right. So this will be the leftmost. So 78 in base 10 is 1 0 0 1 1 1 0 in base 2. And notice I've read that 1 0 0 1 1 1 0 in base 2. And again, if you want to check that, you can pop up your calculator. You can go into the programmer mode, type in 78 in decimal, and then get the binary representation. So let's apply the same logic now, and let's figure out what 78 is in base 5. So again, all I have to do for this is I'm going to take 78, and I'm going to divide it by 5. So 78 divided by 5 is going to give me 15, and that's going to give me a remainder of 3. So then I take 15, I divide that by 5, and that's going to give me 3, remainder 0. And now I'm going to take 3, I'm going to divide that by 5, and that's going to be 0, remainder 3, and now I'm done, because I'm not going to take 0 divided by 5. So notice here, your end mark, I think I actually pointed this out incorrectly in the last one, your end mark is when you end up with a 0 as your result. So therefore, 78 in base 10 is equal to, and again, 303 in base 5, reading it up the line like this. Unfortunately, your calculator, you can't check that one as easily because there isn't a base 5 on here. Now let's do base 16. Now I chose base 16 very deliberately for a very deliberate purpose, and let's see what that is. So if I take 78 and I divide that by 16, so I go 78 divided by 16, and I'm going to get 4, and then now I want the remainder, and I get 14. Now here's the thing, 14 can't be written because it takes up 2 place values. I can only use up 1 place value at a time. So what you can do quickly here on the side is you can maybe make a little chart, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then you can write the hexadecimal next to it. So again, 0 to 9 doesn't change. Oh, pardon me, 0 to 9 doesn't change, but when we hit 10, we go A, B, C, D, E, F. So 14, when I write out the hexadecimal number, I simply write the letter E. So now what I take is I'm going to take 4, and I'll divide that by 16. So 16 goes into 4 0 times, and the remainder is obviously 4. So therefore, 78 in base 10 is 4E. And the nice thing about the calculator is we can check that. So decimal is 78, hexadecimal is 4E, and I'm done. So the key point to this is that when you want to convert from base 10 to base n, you simply continually divide until you end up with a 0 as a dividend, and then you write out the number from left to right, starting with the most recent value. So here 1001110 is 78. 303 base 5 is 78. 4E base 16, which I left off there, is 78. I hope that helped.